Hi girls, let's continue this lesson. I already introduced for you chapter 8, which is talking about polynomials, and we said polynomials means which is many, and nomial means terms, which is many terms. So this is the meaning of polynomial. I started with you and showing you how to classify the polynomials according to the degree and according to the number of terms. And I discussed with you about the meaning of the monomial, which is only one term, and the degree of monomial, which is the sum of the exponent of its variables. We finished the first problem and we finished the second problem, and we also discussed about all these, which is the general meaning of the polynomial and the standard form of the polynomial in the degree of the polynomial, which is the greatest exponent. All right. So I showed you in this table, which is summary, how can you classify the polynomial according to the number of terms and according to the degree. So I also showed you this table, which is more organized and more clear, will help you if you want to classify the polynomial according to the number of terms, and here according to the degree of the polynomial. So we also discussed about that. How can we just write the polynomial in a standard form, then classify it according to the degree and the terms? Just recall that, and let me just do one problem from these, then start and continue the rest in my lesson. So first of all, here I have these two like terms, so I'm going to add them or subtract them according to their sign. So x and x here, they are the same base, same powers. So that means these are like terms. So we can subtract them. So once we subtract them, that will be negative 7x to the power 2 minus 4x plus 4. Now I can write my polynomial in a standard form. This is not simplified polynomial. That's why I simplified it first. So that's why I started also with this question. So the degree of this monomial, you know that each term we can call it monomial. One from these will be monomial. Overall, this is polynomial. So the degree here is 2. The degree here is 1. The degree here is 0. Okay, what is the standard form? It's already in standard form. No need to change the order for these terms. So it's already ready. So writing in the standard form is done. Now, let me classify it according to the degree of the polynomial and the number of terms. So the degree is 2. That means it's a quadratic polynomial, quadratic. So according to the degree, it's a quadratic. So it's a quadratic what? Here we have 3 terms. Since we have 3 terms, we call it a trinomial. So quadratic trinomial. So let me write that. So quadratic I'm sorry again, it's very difficult to write by mouse, but this is the idea. Same thing with this one. Now I'm going to do with you one more exercise to make sure that you are okay with the idea. So here I don't have any like terms, so I just need to rewrite this one as the standard form. The degree of this polynomial, the monomial, here the power 1, so the degree is 1. Here the power is 3, so the degree is 3. Here the power is 7, so the degree is 7. Now I'm going to rewrite this one in a standard form. The standard form is listing all these terms from greatest monomial to the least monomial. So that is, I will carry all this term. Be careful, this negative for this part. So that will be 3c to the power 7 plus, next, this one, 8c to the power 3 plus c. So that's the standard form. Okay, I'm going to calculate according describe it or classify it according to the degree. The degree of this polynomial is what? 7. So since the degree here is 7, I can say 7th degree. 7th degree. 7th degree. Since this is the 7th degree, so then the number of terms 1, 2, 3. So again, it's the 7th trinomial. If you have one more term, you will gonna, if you have, for example, one more term, let's say, for example, 2x2. For example, plus 2, which means 4 terms. You will gonna say the 7th polynomial, not trinomial. It will be polynomial because you will have one more term. So that's the idea for this part. That's, I just review it with you. Then now I will start the new things. So actually it's not a new thing, but we will gonna do more steps. So here, if we have researchers studied the number of overnight stays in United States in national park. So they have 2 different park and they represent the first park in this polynomial and the second part in this polynomial. So the thing is, they want you here to do what? To add these polynomials. So in each polynomial, x equals 0 correspond to the first year in the first 5 years period. What polynomials module the total number of overnight stays in both these campgrounds and in these 2 kind of parks. So what you will gonna do, you will gonna add these 2 polynomials. Again, once you add the polynomials, you will look at the like terms, then you will add them or subtract them together. While if you have unlike terms, you will leave them. There is 2 ways. You can add them vertically like this, which means list the like terms together. This term with this term, they are like term. That means I can add them or subtract them together. So 7.1 x to the power 2. I'm going to write down 21 x to the power 2. Let me change the color for you. We have here x and here x to the power 1. This is also to the power 1. So these 2 are like terms. So that will be minus 8, 0, x. I'm going to write this one down. Negative 1, 40, x. Plus numbers together. That's easy. Just a plus 5, 8, 0. Until now, we did not do anything. We just rewrite again our polynomials down. So that is now plus them. You can just plus them easily or add them. Negative 7 and 21, which is equals to negative 7 and 21, which is equals to 24. Drop your x to the power 2. These two, negative and negative, addition, 180 and 140. So that will be minus 2. You know how to add 200. That is 220 x plus, just add these two numbers. So that will be that will be 6, 7. So that will be this one. That's it. You can directly also, if you have them, sometime you won't have them like this shape. You might have them like this. For example, you will see them like this, 7.1 x to the power 2 minus 180 x plus 5080. You need to add this polynomial with the other polynomial. 21 x to the power 2 minus 140 x plus 1900. You might see them like this. You don't scared. You should not write them like this. It's up to you. Just you need to focus on the like terms. This is the most important thing that you should focus on. So let me go again. This term with this term, they are like term. Yes, I can add them or subtract them together according to the sign that I have. So that will be 24 x to the power 2. Then my eyes will go to the second thing that I have, which is this one and this one. They are like terms, this one and this one like terms. So that will be negative 220 x. Finally, you have the numbers together, just add them together, which is these two numbers, just add them together, which is will be plus 7,700. That's it. So this is for this idea. Use one from the ways. You should not use both of them. You can use just one from them. And that's it. By the way, here I thought that this is 7 only, but it's 7.1. So once you subtract them, that will be 13.9. Even here, it's going to be, so that will be 13.9. Even this number is wrong. So that will be here. This is 7.1. I was thinking that it's 7. So 7.1, and this is minus. Once you subtract these, you will get 13.9. Here, once you add these, you will have a 320. Same thing with this one. This and this number, 13.9. This one and this one, 300 minus 320 x. That's it. Let's move to the next problem. The next problem, again, we have two polynomials. These two polynomials represent something in our life. So we need to add these two polynomials. If you see what polynomials module the total number of pounds in millions of carrots, celery. So celeries and broccoli and so on. So you are going to add them. How can I add them? First of all, I'm not going to rewrite them. I'll add them directly, but focus how I will add. So I'll try to choose some colors for you to make sure that you are okay with the idea. So in the first polynomial, I have x to the power of 3. Do I have anything here with x to the power 3? No, I don't. I'm going to drop this term. So that will be 12x to the power 3. It's like I will add this term with nothing like this term. So just to drop this one. It's like this plus 0x to the power 3. Nothing like this term. So this term plus 0, which is equal to 0, it's this term. All right, next. This term. Is there anything like this term? Yes. We have this term x to the power 2, and we have this one, 14x to the power 2. Okay, great. So I'm going to add these two monomials, let's say. So that is 106 plus 14, which is equals to 120. This is plus, positive, and this is a plus, so I don't have a problem. So that is plus 120 x to the power 2. Next, I will see my next term. So it's given a number, x. My focus on x to the power 1. Do I have like this term? Yes, I have this one. X here to the power 1. Yes, so these two are like terms. So I will focus on my negative here. Negative and negative here. So these will be, I will negative 241 plus, that's what I'm adding these two polynomials, minus 14. So it will be plus. So I'm going to add them. So 241 and 14, both of them minus. So that will be minus 255. Finally, the last term that I have is just a number. So a number, and here is a number. Just add them together and then put your result. So we had 4477 plus 1545, which is equals to plus, since both of them plus, so plus 6022. So that's it. So it's really simple. It's really easy if you focus and do step by step. Focus step by step. I don't care if you write it horizontally, vertically, if you just do the same way that I did directly, it is up to you. Let me do with you more exercises. So here it's already easy and it's already ready. So just add these two. These two are like terms. So 4 plus 9, it's 13w. 13w, and we have here negative 5 and 2 will be minus 3. This one, as I told you, I should not waste my time and rewrite it. This x to the power 2 and here x to the power 2. I'm adding them. This is 5 plus 15. So that will be 20 x to the power 2. These two numbers, which is exactly same. These two are like terms. So that will be plus 3 plus 2, 5. I'm done. Move to this one. Exactly same idea. These two are like terms. I'm going to add them. So that is 9x to the power 2. 7 plus 1, 8. These two. Okay. Here I have g to the power 4. Should I add it with g to the power 3? No, I cannot add it at all. So let me do the same thing that I did step by step. So is there anything like this term? No, nothing, just to drop it. 2g to the power 4. Next. Do I have anything like this term? G to the power 1. Yes, I have this. G to the power 1. So which means these two are like terms. Negative 3 and 12 So that will be negative 3 and 12, which is 9. Positive 9, because 9 is bigger. So positive 9, G. Finally, I have one more thing. 9. Is there anything with this 9? No. So plus 9. There is something I should not forget it. The last one. I did not do anything with it. I must drop it as it is. There is nothing to add with this one. So just minus G to the power 3. So that's the idea. Let me do with you this one also to make sure that you're okay with the idea. Make sure that you try them once you work. So 7k to the power 2, because these are like terms. Here minus and plus 3, so that's plus 2k. Finally, we have plus 3 minus 7, which is minus 4. So that's for adding polynomials. Now, let's move to subtracting polynomials. It is exactly the same idea. You don't need to worry about it. But there is a very important thing you have to focus on, distributing this negative. So once you subtract, distribute first, then deal with it exactly the same as addition. Maybe there is another way in the book, but this is much easier for you to avoid confusing. So that's 3x to the power 2 plus 5x. Now, once you distribute this, you will have negative 7x to the power 3. You will have minus 5x to the power 2. Minus minus, it will be plus 12. Now deal with it exactly the same addition. This is easier than do anything else. So just take this one with this one. They are like terms. So x, the coefficient is like 1 here. So 1 and negative 7, that will be negative 6 to the x to the power 3. Then let me change the color for you. So we have this term. Is there anything like this term? Yes, we have this term exactly same. So negative 3 and negative 5, both of them negative. Negative 3 minus minus 5, which is negative 8 x to the power 2. Next, is there anything to add with this one? No, I don't have anything to add with here. This is just, there is nothing like this term. Just drop it. Don't forget the remaining thing from the other one. So, which is this one. Nothing to add with the 12. There is no number alone. I'm done. So that's the idea. Let me do with you this one also. I'm going to copy it here. So I have negative 4m3 minus m plus 9 minus 4m2 plus m minus 12. So since I have again parentheses here, I must, even if they say subtract or add, I am not worrying about them. So I will distribute my negative sign so I can remove it. I'll drop my polynomial m3 minus m plus 9 minus 4m2 minus m minus minus plus 12. Now step by step, I will add like terms together. So is there anything to add with this one here? No, it's just this one. I will drop it as it is. Next, I have This one, is there anything to add with? Yes, m to the power 1, m to the power 1. So these two are like terms. That's a negative one. The coefficient here, negative 1. The coefficient is here, negative 1. Negative, if you remember, as I told you before, if you have one bag and plus one bag, it's two bags. So that is negative 2m. Here we have 9 and 12. They both numbers. So 12 plus 9, which is equals to 20 plus, both of them positive. Please be careful for the sign. So that is 21. So that is 21. The remaining thing, there is one term I did not do anything with. There is nothing like this term also. I have to drop my term as it is, which is this one. The last one is this one. Just take it, write it here. Minus 4m to the power 2. So that's the answer for this one. That's the answer for this one. Let me give you more exercises. So to have more exercises, here again I have to focus. Look, there is parentheses. I have to focus especially with this one. I might not confuse with this part, but I might confuse with this part. Here, be careful. It is negative. You are minusing it. So let me rewrite this one here. It is up to you if you want to keep it like this and directly work on it and say, Miss, I know that I can figure it out and focus directly that this minus it's for here and here. So you can say directly that's 5 minus 3, which is 2n, minus 2 minus 8, which is minus 10. If you feel that this is confusing you, you can directly write 5n minus 2, and here you can write negative 3n minus 8 and do your calculation as an addition as I did before. So let me continue this one. So this will be, I will drop this 14 h to the power 4 plus 3 h to the power 3. I'm going to distribute this for all terms that I have inside. So minus 9 h 4 plus minus 2 h 3. Now I will search for all the terms. If you remember that we learned something similar to this one, but we called it before algebraic expressions. We did not say polynomials, but now you deal with it as a polynomial. Because polynomials has special properties and you will gonna learn more details on the coming days. So 14 h to the power 4, it is like this term negative 9h to the power 4. So I'm going to, since they have different sign, so I'm going to subtract them. So once you subtract them, you will have 5 positive 5h to the power 4. So next we have anything like this term. Yes, we have this term. So 3h to the power 3 minus 2h to the power 3. So 3 minus 2, it's plus 1. Plus 1h to the power 3, which is exactly the same as if you don't write anything here. 1h, which is h like this. Here again, you can directly put your minus here and directly work on it, and the minus here for this one also. So 6 minus 4, 2x to the power 3, 17 minus 9, which is equals to 8. So plus 8, 17 is bigger, so plus 8. Now this one, again, you will change the sign. Once you distribute, you will change the sign that you have. That will be plus, and that will be minus. You can work now directly. So 2 minus 1, it's 1c. c to the power 2. Here, this will be plus, because minus minus a plus, so 7 plus 10, it's a plus 17c. Minus and minus, it will be minus 5. Minus 1, minus 4, it will be minus 5. We are going to do also this one. I can directly distribute my negatives to avoid confusing. So that is w to the power 3 minus 4 w2 minus w. We have here also negative 6 w4 plus w2 plus this one. Now I'm going to add this one, 6 to the power 4. Is there anything here with 6 to the power 4? No. I'm going to drop negative 6 w to the power 4. Now, next we have, let me change the color to, this is to the power 2. I have this one also like this term. So plus, or will be minus because that's bigger. Negative 4 and 1, 1 and 4, it will be negative 3 w to the power 2. This one, nothing to work with this one, nothing to add with this one. There is no like terms here. So I'm going to drop this here as it is. So plus 2w to the power 3. There is one more term, which is also not like the first one. So that will be minus w. This is the answer. That's for this part. Here is just a quick and just a quick review for this lesson. So we have this. So I'm going to review it with you. Find the degree of the monomial. So the degree of the monomial is here. The degree is 4. The degree for this one is 2 plus 3, which is equals 2. The degree here, which is equals to 5. And here you just need to add them exactly the same way that I did. And you just don't forget to, that's, I'm not going to give you anything more than this lesson for today. So that's for this part. Good luck, girls, and bye.